Welcome to 254 VEX Talk. I'm Lucas, and today I will be giving an overview of various types of lifting mechanisms commonly seen in VEX. For every task, there is a different type of lift that is well suited to completing the objective. Depending on whether you are building a robot built for speed, power, offense, or defense, you'll need to consider which lifting mechanism best fits your needs. One of the simplest and most practical lifts in a VEX is the arm, a simple joint with an intake or claw mounted to it. This allows the arm to raise or lower quickly, and this joint adds very little weight to the intake. However, a simple arm often minimizes the reach of a robot and also creates a varied angle, which may cause problems when intaking or outtaking. Another basic design is a 4-bar linkage. A 4-bar linkage is one of the most versatile lifts you can build. It is well suited for almost any type of intake and is relatively easy to build. It is also very lightweight and simple compared to other lifts. Although a 4-bar system has its advantages, it also has some key disadvantages. If built improperly, it can be very unstable and wobble a considerable amount. This can lead to inconsistency and other problems, which you never want in a VEX robot. The next lift I will talk about is a 6-bar linkage. A 6-bar linkage is very similar to a 4-bar linkage, but with some key differences. The design of this lift allows for a higher extension of the robot's arm, which can sometimes be an essential part of a VEX game. However, the 6-bar is less stable than the 4-bar because of its shear strength and the increased wobble caused by its longer length and added joints. This disadvantage can often be minimized with crossbars and efficient spacing. The other disadvantage of the 6-bar is that it is obviously heavier than the 4-bar due to the increased parts it uses. The next most common lift is an elevator lift. This can be considered more of an advanced lift due to its complexity and difficulty to build. Although anyone can build an elevator, it takes a great designer and considerable determination and time to build a decent elevator that is both quick and consistent. Complications also arise with the many different types of elevators that you can build. These range from the number of stages in your elevator all the way to your rigging system. When building an elevator lift, it is important to consider how many stages your elevator will have. You must realize that with increased stages, there is an ability for increased height extension, but with each stage there is an increased potential for problems, including jams and friction. The advantages of an elevator lift are both its speed and extension capabilities. A well-built elevator should be able to rise to considerable height in a very short amount of time. The disadvantages of elevator lifts are both their complexity and their high potential for problems. They can also be very heavy if not built properly. The complexity of elevator lifts and the high number of connections generally leads to jams and tension issues. The last type of lift I will talk about today is the scissor lift. Scissor lifts have overlapping sections which extend in a crisscrossing manner. The advantages of a scissor lift are its large extension height and its very small retracted height. This allows for a robot which can reach both tall objectives, but also fit under small objectives if the need arises. The main disadvantages of a scissor lift are the obvious increase in height due to the many crossing bars lift uses to rise to its large height, but also the general instability of its design. Many scissor lifts, when extended to their full height, are usually considerably unstable and prone to tipping or jamming.